In this video, we are going to continue to look at the concept of function by looking at the idea of range. So we've previously talked about the idea of domain, and so range is really sort of the opposite concept from domain. So whereas domain was the x values, range is the y values. And that means it is the dependent variable because it depends on what number you plug in for the x. So it is dependent variable. And it is the output, so it is the answer. And it is graphed on the vertical axis. Now, the great news is that working with the range is a whole lot easier than working with the domain, because the domain we have to figure out what numbers we cannot put into the function, but with the range, we're just getting an answer. So we don't have to worry about restrictions. We do have function mapping as a related concept that helps us picture the domain and range next to each other. So a function mapping uses two circles or ovals. And so I'll draw a picture here. So we have oval and oval. This one is our domain. And we know domain is the input or the x value. This one is our range. And we know that that is the output, the y value, or the f of x value, the function based on x. So in our domain, we can have all kinds of numbers that work. And then to get over to the range, we have what we call the function rule. And a function rule is none other than an equation. And so throughout the semester, we'll deal with all types of equations, some of which are function rules and some are not. Some are just relationships, and they help us to get from one, the domain, to the other, the range, and we'll use our calculator for a whole lot of help with that as well. So then we get this idea of, well, if some are functions and some are not, what is it that makes it a function? So we're going to start by looking at examples, and then we'll actually write a definition. So the first example that I have here is my domain, which is my x. And here is my range, which is the y. And in my domain, I have the numbers 1, 2, and 5. In my range, I have the numbers 2, 3, and 6. And my function rule, works this way. The 1 becomes a 2, the 2 becomes a 3, the 5 becomes a 6. And this is a function. We'll come back and talk about it a little bit more, but let's look at another one. So in this one, I'm not going to write quite as much here, but I have my x values. Over here, have my y values. And in here, I have 1, 2, and 5. And over here, I have 6. And the 1 will go to the 6, the 2 will go to the 6, the 5 will go to the 6. And again, this is a function. And my third example, so I have my domain, which is the x. I have my range, which is the y. And here I have 4 and 16. And over here I have 2, -2, 4, and -4. And the way it works is the 4, you can go to the 2, or you can go to the -2, whichever one you pick. The 16, You can go over here to the 4, or you can go to the -4. Again, whichever one suits your fancy is going to be fine. And so this one is not a function. Now, you may remember that when we were talking about domain and related concepts to a function, we talked about the idea that a function is one-to-one. And so as a definition, this last one violated the one-to-one property. So that's why that's not a function, and that's because it's not one-to-one. Now, you may be thinking, okay, the second example didn't look one-to-one either because I have 3 different numbers and all of them gave you the answer of 6, but you said it was a function. So we actually have to write out a definition. So what is a function? It is the correspondence that assigns to each element of the domain exactly one that's the key, the exactly one element of the range. So the first one, each element of the domain, those 3 numbers, went to exactly one element of the range and it met the definition. In the second one, we see that each element, the 1, the 2, the 5, went to exactly one spot in the range. Although they all matched, it's okay. They all only go one place. It's a function. In the final one, it is not a function because each element in the domain goes to 2 different elements of the range. So there's not just one path across, there's 2. If I start at 4, I can end up at 2 different places, and that is not a function. So this is that idea in math that there's one right answer instead of 2. And that idea isn't true for all of math, but it is true for functions. A function rule has to give you one right answer, cannot give you multiple answers. So let's go back and add a layer to this where we're talking about the function notation. So for this first one, I can see that whatever the x was, the y value is 1 bigger. And so I see the rule as being x plus 1. And so the way that I would write that in function notation is I write f of x equals x plus 1. So the x here is the domain, and the f of x as a group, it's not a multiply, it's a group, and that is instead of y, and that is the range. Now, the notation would allow me to do things, and let me switch colors here so that because my screen is getting rather cluttered. If I would be asking you f of 2, what that means is that you replace the x with a 2. And so I would say f of 2, and I'm going to show all my work here, equals 2 plus 1, putting the 2 in where the x is in the formula. And then I could say f of 2 gives me an answer of 3. Okay? So then this second example that is indeed a function, this one, if I look at what the function rule would look like, it would just say f of x, function based on x, is equal to 6. And so this one does not have an x in the formula because I don't multiply or add or divide. I don't do anything with the x. I just always give an answer of 6. So for this one, if I would ask f of 1, well, I can see this in the diagram that the 1 points to the 6, but that is 6. But if I asked you for one that's not in the diagram, so what if we were asked f of 15? Well, when I look at my function rule, there's no place to plug in a 15. It just tells me this function always gives an answer of 6. Now, this final one is not a function, and so because it is not a function, it cannot be written in function notation. And so that's a big deal. We can't use function notation. So I can't write it f of x. It just doesn't work. The formula that is at play here would be that y equals plus or minus the square root of x. So you can see that if I take the square root of 4 and I include the positive and negative ones, that would be the rule that is demonstrated in this mapping. But because of that plus or minus in there, it violates that exactly one idea, and so it is clearly not a function. So the next thing that I want us to take a look at, we'll put the next thing in the next video. So we'll end this video here. Thanks for working with the idea of what is a function and what is the range.